All right, so let's go over just a quick question or two on mix yield and overhead, just to keep the promise of reviewing those, finishing up those, because we do have those. This quiz extended through this Friday. So let's look at a yield variance problem right here. How about that? So the firm's standard mix on inputs for a finished goods unit is 1 unit of input A for 4 units of input B. The standard price for input A is $4, and the standard price for input B is $2. So it's going to be relevant because we're going to have to create the price of a unit at standard mix. That's the equation here. Let's open up. You'll have this on the exam. That is, you'll have, because you'll want this. You'll have the equation written down on the exam. It's right here. We're going to need actual yield. We're going to need standard yield. We're going to need standard price at standard mix. Okay. Yeah.
Sorry, one more question. You said we get some sort of note sheet for the exam. Is that a note part or is that?
An 8.5 sheet, front and back. You can do it typed. You can do it handwritten. Yep. You can do a mixture too if you want. Wait, where's our question? Here it is. Okay. So yeah, we're going to need this right here. So that first paragraph is entirely to help get us the standard price and standard mix. All right, at standard mix, the standard input number of units, standard number of input units per finished goods unit is 5. So for every 5 units of input A and B, overall mix of total input units we should get 1 finished goods unit out the other side. The firm actually completed 40,000 finished goods units and use 180,000 input units. So that's not a 5-to-1 ratio there. That's going to be our actual yield right here. And we can take that 5-to-1 to figure out what we should have yielded given 180,000 input units. So let's go put this into Excel here. This is yield problem. All right, so actual yield, 40,000. No, number doc. And then standard yield. We have actual inputs, standard inputs per FG unit. That's 180,000 from the problem. And 5. That's what the problem said. We actually used 180,000 input units. Just A and B together is 180,000. Input A and input B. And our standard is to have number of input units per 1 finished goods unit is 5, so 5-to-1. So 5 inputs per finished goods unit, input units per finished goods unit. So our standard yield is going to be, given 180,000 input units, we should have had 1/5 of that in finished goods unit. We should have 36,000. So we have a favorable variance. We don't have the number, but we know it's favorable because our actual yield is 40,000. We got 40,000 output from the 180,000 inputs. Given our standards, we should have gotten 36,000 outputs. That's favorable. We got more than we bargained for. The yield is the weird one. The signs are going to be reversed. So this will give us a positive number, but that's a favorable variance in the case of yield. We're holding constant instead of how many finished goods units there are. We're holding constant how many input units there are, and the yield or finished goods units are moving up and down. So if it's positive, that's going to be favorable. And we have to multiply that by that standard. Oh, wrong one. Oh, where we go? What is the right one? It just moved on me when I shrunk it. Okay. We need standard price at standard mix here. So standard price at standard mix is the standard input price for a single finished goods unit. All right. So we have each finished goods unit is going to carry 4 units of B at $2 per unit and 1 unit of A at $4 per unit. So let's figure out what that standard price is. We have a little table, A and B. Call this the mix and the price. Make sure we clear this. This is the standard mix. This is the standard price. Is 1 to 4 and $4 and $2. So 1 unit A at $4. So we have $4 of cost from the A inputs in each finished goods unit, and we have 4 units of B at $2 per unit, $8 of B cost, of unit B cost, input B cost in each finished goods unit. So the sum of those two is each finished goods unit should cost us $12 worth of input units. Okay, that's our standard price at standard mix. That's what that means. SP at SM is standard price at standard mix. So we have actual yield. No, we'll put parentheses. Actual yield minus standard yield times our actual, or our standard price at standard mix. So it should be $48,000, and we said it was favorable as well. How's it looking? All right, yeah, I recommend on the note card, or the note page, you have the variables, list the equations for mix and yield and overhead, fixed overhead especially, because it's different than the variable overhead, direct labor, and direct materials, which those three follow a similar pattern. Fixed overhead's an odd man out, and mix and yield are of a different kind of different variety as well. All right, should we do a mixed problem? Yes, we'll do a mixed problem. Do an open answer because we like open answer problems. Okay, here is an open answer. So we're going to build our table here for mix. I know actual total inputs here. So I'm going to rep text. We have actual input mix. We have standard price, and then we have a subtotal here. And then we contrast that to all the same fields except now standard mix. It's mixed variance because the only lever we're pulling is the mix. And there we go. All right, the problem says we have two inputs, X and Y, right here. All right, so X, Y. And we expect at standard mix 1X for every 15 units of Y. And our standard prices are 22 and 6. That can go on both sides of this table, 22 and 6. We actually use 10,000 units, so that's all 4 of these cells, with 2,000 units of X and 8,000 units of Y. So what that means is, out of the 10,000, we have 2,000 that are X, and out of the 10,000, we have 8,000 that are Y, leading to an actual mix of 20 to 80%, or 0.2 and 0.8 here. Our standard mix, I got to rephrase that in decimal point here. So out of total of 16 here, one of those 16 is X, and 15 of those 16 are Y. I'm hard coding a lot of stuff in this problem. I don't have a list of fact pattern things that I'm referencing. A lot of these things are encoded in the cell. So I'm going to multiply across. The great thing about this table is you don't have to remember too many steps as far as how to get these subtotals, just multiplication all the way across. Every single subtotal is just multiplication. This times this times this equals that. And then you sum. And you sum here. And so with the actual mix, we had costs of $92,000 because we used way more of this X, which is the more expensive unit, than we expected. We used 20% of our inputs were X. It should have been 6.25%. So we way overused X relative to Y. So we have 92,000, whereas standard for 10,000 input units would have been $70,000 worth of cost there. And so we can subtract these, this minus this, we'll get a positive, and mix is not weird like yield. Oh, I misspelled it in a lot of ways. Favorable. So positive means unfavorable. 22,000 unfavorable should be the answer there. Is that okay?
Could you go to cells 815 and 816?
Yes. So I have in here 1 over 16 for x. This is the x's standard mix because it says 1 unit of x for every 15 units of y. So total, there's 16 units being expressed here, 1 plus 15. So 1/16 of the input units is x, and then 15 of those 16 input units are y. Good. All right. Let's see if we got those right. Tell the truth. 0 points. What do we get wrong? I didn't answer anything. What?
For cells C15 and C16, you could just divide how much you actually made.
C16 and C.
So the 2,000 divided by 10,000.
Yep.
If it was like a weird number.
Mm-hmm. Yeah, and you probably will need to. Some of the problems will be randomly generated, and so it'll be a weird number, and so yeah, that's how you get it. Yeah. I'm not sure why it didn't count it because these are entirely different questions that it has here. So when I push submit, I think the problem might be that I have multiple quizzes that I've previewed at once. So I've got chapter 8 quizzes previewed. That's my best guess. That's all I got. Do I have? No, this is the overhead one. I'm not sure. I don't see the 2 questions that we did here. So I'm not sure. I can't explain it. And right now I'm not interested in taking Canvas to the couch and being like, what is your childhood like, and why is this problem arising now? I feel pretty comfortable with how we did those questions. All right, I'm gonna stop there. So if we have time at the end, we'll come back to this. Let's do one fixed overhead question. Do you want a volume or a spending variance? Because I know I heard spending. Okay, first come first serve. Somebody said spending. Fixed overhead spending variance. Let's find one if we can. Oh, there we go. This will have to do. And this might be one where we have cannot be determined. But if we can't determine it, I will put in a number of whatever we're lacking so that we go through the calculations overall. All right, so let's go back up to overhead and our weird fixed overhead mountain range. So from actuals to quasi-budget, to flexible budget, to static budget, all that is the spending variance. And we have the weird volume variance on the other side of fixed overhead, which takes the static budget and makes it more hypothetical because it's based on the application of cost through the PDOH contrived mechanism of allocating overhead to units as they consume cost drivers, which is contrived because fixed costs should be fixed. They shouldn't be moving based on how many units consume cost drivers. But we're talking about the spending variance, which is actuals minus static budget numbers. Where are we? This one right here. All right, so the firm's static budget predicted $250,000 in fixed overhead costs. Well, there we go. That's one of the boxes. Oh, where'd it go? Right there. That's this box right here. So something minus $250,000. The firm's PDOH is $40 per machine hour, 75% of which is was for variable overhead. All right, so what that means is we have an overall overhead rate that we're charging each unit of $40 per machine hour that the unit consumes. And $30 of those, or 75% of that, is for variable overhead, which means the remaining 10, we're effectively charging every unit $10 per machine hour for fixed overhead costs. What we can do with that is we can derive also the standard quantity if we needed to. But we'll move on. The firm's actual machine hours were 24,000. The firm's actual fixed overhead costs were $265,000. All right, well, I think I have the two boxes. It gave us the actuals right here and gave us the static right here. So as tempting as it is to say, oh, no, there are two cannot be determined, this must be a trick here. And there's something important about why we can't determine it. And that's why what he's testing me on. I actually do think this is a can be determined. It's going to be this $265,000 minus the $250,000, which is $15,000. And the question is it favorable or not? Unfavorable? Okay. Why? Yeah, when we move to reality, it's 15,000 more than we budgeted. Closer to the real number, higher than the lower number, more costs, all things being equal, is worse than fewer costs. Good. Okay. Maybe that wasn't the most satisfying fixed overhead spending variance question. If there is such a thing as a satisfying fixed overhead spending variance question, maybe this wasn't it. But we're gonna move on, and we've got today and Thursday to kind of work around with this, and maybe the end of the class today. So let's talk about lean accounting. And yes, I've got a classical music joke in here, but we'll move on from that. So the basic idea is this equation right here. So we started in chapter 1 with the idea that profit equals revenue minus cost, and that's real simple. Congratulations. Your first day of business school. But the idea is we have different drivers of revenue and different drivers of cost. And we just put a dot in this math instead of filling it up with a bunch of different variables that are supposed to be driving it. So the idea is there's some function, x1 times 3 plus x2 over 5 plus negative x3, whatever function, something. We don't know yet. It's just all hypothetical at this point because we're talking about it in the abstract because we want to get general principles out of it. So we've got to zoom out and say, we're not worried about the specific shape of the function right now, just that there is a function. There's some revenue function. We put just a dot in there. So now I'm going to populate with some x's and their subscripts. And with cost, we also just put a dot inside the parentheses, and now I populated it with x's. Now, what do you notice about those x's? I don't notice them. They're my x. Oh, yeah. What about those x's? Anything about those? That's a great observation. Yeah. So these three are repeated, and these two only drive revenue. These two only drive costs. Yeah, those two don't correspond. The first three do. In a nutshell, that is the lean mindset, is the fact that there's an X1 in revenue and an X1 in cost, an X2 in revenue, an X2 in cost, an X3 in revenue, and an X3 in cost. If you're strictly following cost accounting to its logical end, you will be grinding every employee for every second of his or her time until they want to quit. You'll be chipping away at quality as much as you can until you are producing garbage that nobody wants to buy. You will be driving down costs to be more and more and more efficient, including driving down X1, X2, and X3 in this example that are driving cost. And you might be ignoring that they are also over here driving revenue. So a quality product is more expensive to produce, but if what you are selling the customer depends on, their interest in the product depends on it being a high quality product, then you can't just cut those quality costs and make a really cheap quality product, or low quality product, really cheap product, and expect the same level of revenue. And the goal here, the key is, we started in chapter 1 with the idea that we call this class cost accounting, and the tools here are often called cost accounting tools, and people who use these tools are sometimes in their title called cost accountants, because of the two general ideas that go into profit, the cost one is the one the business has more direct and immediate control over on average. It can directly influence costs. Revenue, it has to convince a customer to voluntarily give money. So there's a second party, and so there's an extra step before you can make changes on the revenue side. And so a lot of the management systems are focused on, we need to control costs, and that will drive profits. But in the end, they're not called a for-cost firm. They're called a for-profit firm. They're for-profit companies, not a for-cost company. In the end, their goal is to maximize profit, not just to minimize cost. You only want to minimize cost insofar as it maximizes your profit. And so lean says, hey, look. We've got some things that are just driving cost, and let us go hog on those things. Let's just rip and attack that waste. We want to be lean and get that waste out of there. But there are other things that are driving costs that are also driving revenue, and they're part of our, this is the terminology they use, value stream. And so we need to protect those from the machinations of the evil cost accountants, and we need to expose these to the furor of the righteous, mighty cost accountants. So I've just I don't know how that metaphor works, but the idea is very much directing your cost accounting activity, your profit maximizing activities. All right, so the idea is we have a value stream. So we're doing something to the customer. We're giving something to the customer. And it's kind of encapsulating the idea of what drives the revenue function. The customer wants something from us, otherwise we wouldn't be in business. We're providing value to the customer. And so there are a stream of activities that bring the customer from order to delivery, things that we do for the customer that are useful and are driving revenue as a result. Those things cost us some money, and they're going to be protected. We want to protect those kinds of value stream costs because they represent something that the customer wants. All right, so also I include in here the idea that this is an emergent and organic kind of movement over the last couple decades. Lean roots back further than that, but I think a lot of it has gained prominence over the last couple decades. And so a lot of terminology has not quite settled in yet, and there are a lot of disagreements about how exactly to do this. This chapter represents my best effort to distill central tenets and overlap from a variety of different disagreeing sources. So what I figure is that the center of mass of lean accounting is the idea that we have at least as far as value streams are concerned, value stream income statements are concerned, that we have a value stream income statement that does all three of the following. And we go over each of those three. So number one, does not use variance adjustment and only reports actual costs. So basically, if you did not like the last few weeks of class, minus spring break, of course, the chapter 7 stuff, you like this because they're like, we don't need no variances in here. So here's an income statement. If you are in a standard costing or variance analysis kind of firm, you have sales revenue minus whatever sales returns. So you have net and service revenue, and you have your net revenue then, minus cost of goods sold and a gross profit number. If you're in a standard costing firm, this is cost of goods sold at standard. Remember, you're debiting to work in process at the standard cost because you've peeled away all the variances. And so work in process is expressed at standard, and so when it's credited and it debits over to finished goods, that is also expressed at standard cost. And when that's credited and you debit over to cost of goods sold is still expressed at standard cost. And so this is a standard cost number. It's not the actual cost of your goods sold. This plus all of this is the actual cost of your goods sold, and which would also affect what the gross profit number would be. And so after going through all the chapter 7 instruction, a certain percentage of accounting students understand how to read this income statement. Not directing this at anybody in the classroom, not us. I am saying that I know I have followed up with graduate students after they've received lots of standard costing instruction, and we still have to review. And these are people who are accounting majors. Now imagine you're for management or for marketing or from engineering or something like that. You have had no standard costing instruction, and they show this to you. Oftentimes, this is unreadable to most people who don't know exactly how these variances are calculated and what they mean. It's not as useful. That's at the very least, that is the lean accountant or lean practitioner's argument, is as much as you say this is very useful, nobody knows what this means. It's a different language. maybe if you could learn the original Greek, it would be beautiful poetry, but now nobody knows ancient Greek, and so it's not important to us. So that's kind of the argument that they're making. I'm not saying that's literally true. That's their argument. So instead, value stream income statements, they omit the adjustment of variances. They don't do this kind of thing. Everything is expressed at actual cost. And so all of these cost categories, this is kind of an example of a value stream income statement. All these cost categories are the actual amounts cost, the actual amount spent. Our actual cost for materials are in this row right here. Our actual cost of direct labor is in this row right here. Actual cost of support labor, et cetera, et cetera, et cetera, et cetera. Actual. Nothing is expressed at standard. We're not peeling away those kinds of variance numbers during the process. First characteristic there. All right, everything's at actual. Second thing is, as you can see, that's the question of what these rows represent. Second is that we separate out value stream costs, and that is in the columns here. So the idea is we have some value streams, and these are the protected classes of costs, or that is to say, they are much less likely to include waste or include things that don't also drive revenue, costs that also don't drive revenue, than the non-value stream costs. We want to separate them out. And so oftentimes you'll have a tiered system. You might have just two tiers, value stream, non-value stream. But sometimes you'll have value stream and then supporting or something like that, some sort of, let's see, support, where is the quasi-value stream or for non-value stream costs that sustain the business and products over the long term. So yes, product development and sales and marketing, we might say that's this middle tier of, they're not exactly value stream right now. This does not directly help us take a customer today from order to delivery, but it does in the long term help us take customers from order to delivery. And so we're going to put that in this middle category of we'll put it on kind of yellow alert here. Maybe it has some waste in it, maybe not, but it does help support value stream in the long run. It might be driving both cost and revenue. That's what that means. And then we have the bottom level support. So these are costs that are these are costs that are relatively likely to have waste in them. So we have to have extra special care over what we're charging our company over, what expenses we're incurring over there. All right, so that's the second thing. We're going to separate out different columns of things that bring in value and the costs associated therewith, right here in the orange. Kind of the medium, at least some lean firms do this, kind of these long-term costs that support the value streams but aren't directly bringing customers from order to delivery. And then these non-value stream costs or support costs or other costs that, you know what, they are not in the value stream, and so we're going to make them be suspicious about them. I'm struggling with the words because I don't want to say they're very likely to contain waste. That's not the case. But relative to value streams, the idea is that they're very likely. So maybe value streams have a 1% chance of it containing waste, just as an example. The support areas might have a 5% chance. So still a small chance, but that's a 5 times increase. So if you're going to focus your economizing, cost minimization efforts somewhere, let's take that support level, which has a 5% chance of containing waste, and really examine the line items there. That's the mentality, at least. All right, and look, I want to acknowledge before we get into any problems, because as you're going to see some of this, there are some similarities to process costing. Because at the very beginning of chapter 6, let's go back to that. The core of the process costing idea actually is really simple. The difficulty all arises because to make it fit how procedures and manufacturing actually works, you have to incorporate a variety of complications. With a lean firm, we're doing this kind of process costing thing, but we're staying at the simple version. Where the complications that we found in chapter 6 don't apply, or they're intentionally ignored for simplicity's sake, because the last thing a lean practitioner wants to do is have to do a bunch of crazy calculations that we did in chapter 6. They're like, that's not worth my time. It's not worth me paying somebody else's time. Let's make this simple and readable to everybody in the company so we can all be aligned on what we provide as value. That's at least a version of what a lean practitioner might say. So the last thing to say is that the last characteristic that exemplifies value stream income statements is an inventory adjustment. All right, so that's the idea down here. We have our opening inventory value and the closing inventory value and an adjustment based on that, which is going to affect net profits. So what that is reflecting is the idea that some of our income statement is affected by the fact that we have released value from the balance sheet by moving inventory values from high to low. And we want to single that out. Now, this is still happening behind the scenes under normal income statement. A value stream income statement wants to highlight that this is part of what's happening with the income statement, that the income statement is moving up or down because we've released a lot of cost from the balance sheet. So let's say we had a big backlog of work in process and finished goods, $1 million worth of backup, $1,181,000 worth of backup. And we have, because we're trying to be lean, reduced inventory considerably because extra inventory is a cost that, or is associated with costs that are just waste. That's the lean practitioner speaking there. And so we've reduced it. What that means is that a lot of that cost has gone through to cost of goods sold, $500-something worth of it, and that is affecting our net profits. This is actually something that they would really like to see. They really want to see a big cost right here at the beginning stages of applying a lean mentality. You want to see this be pretty large because that means you're reducing your inventory backlog. You're reducing the inventory you have on hand. Lean practitioners generally don't want to see that. So they want to have line of sight on how much they're reducing their inventory. Now, over time, once you've been in the lean business here for a while, you don't want that number to be too big because you should have low inventory levels from period to period. All right. So there are some questions in chapter 8 about value stream income statements. And these are some of the few conceptual questions in the course. And they generally are understandable if you remember those three and some details about those three characteristics of value stream income statements. So let's look at this question right here. Scrooge Industries just adopted a lean philosophy this year and now uses value stream income statements. Which of the following is most likely part of this year's value stream income statement? An adjustment for over-applied overhead, an adjustment for under-applied overhead. Well, that sounds a lot like adjustment, sounds like a standard costing kind of thing to do or a traditional absorption costing thing to do. So I'm dubious about these two, and I think one of these two will be literally line up with something we learned from point number 3, characteristic number 3. A large inventory adjustment that increases income located toward the bottom of the value stream income statement, or a large inventory adjustment that decreases income located toward the bottom of the value stream income statement. All right, well, I think I just said when they start practicing lean, they would expect a large adjustment here towards the bottom of the income statement. But the question is this increasing income or decreasing income? Well, here's our income, our value stream profit before. Here's our net profit after. Did that $500,000 likely increase or decrease? It decreased, yeah. So following logic of how I use my hands here, these are balance sheet accounts, and this is the income statement account. And so if we're moving value that's stuck here, debits that are stuck here, they're going to end up being debits over here in cost of goods sold. That's an expense account. It's going to go up, more expense, releasing a lot of cost over there. So I would expect very much to have this be a big cost that's decreasing. I think that's going to be the best answer. That's most likely to be part of this year's value stream income statement. I'm going to get rid of these because I see the word adjustment. And point number 1 says we don't have variance adjustments. Now, yeah, let's leave it at that. Okay, let's look at this one too. Under a lean accounting approach, some costs cannot be directly traced to the value stream. Okay, remember, they cannot be directly traced, meaning they're in one of these columns perhaps. That's probably what we're going to be asked about. Which of the following is true about these costs? Ooh, there is one phrase that's in these questions here, these choices that I did not use that I should use. It's in the textbook, but I'll use it here in a second. Okay, so these costs are managed through a process of continuous improvement because they have a relatively high chance of being non-waste. Okay, I think this would be true if we were talking about costs that can be traced to the value stream. Here's the idea. This phrase right here is often what is used, a process of continuous improvement. So for X1, X2, and X3 that drive both cost and revenue, over time, you would like to get those optimized, for sure. Like, you don't want to be spending extra on employees if you don't have to, even though they are important to the value stream. So over time, you're going to try and, what is the exact amount I need to pay to get just the optimum amount of quality from employees, but not wasteful, you know? You're playing the, a little bit anyway, the Elon Musk game of going into Twitter and kicking out a bunch of employees. You're like, well, yeah, the employees are important, but there's a lot of fluff there. Let's kick some out. So the idea is over time, through a process of continuous improvement, you're going to be wanting to optimize X1, X2, and X3 that drive both costs and revenue. Those are value stream costs. And yes, it would be true if we were talking about value stream costs, this one right here. But we're talking about costs that cannot be traced to the value stream, non-value stream costs. So this is not accurate for those. Okay, these costs, non-value stream costs, these costs are given additional scrutiny because they have a relatively high chance of being waste. That sounds exactly like what I said a few minutes ago. Like, they have a relatively high chance of being waste because they're non-value stream. So we're going to apply additional scrutiny. That probably is the answer, but let's keep going just to check. These costs are charged to inventory through backflushing, especially if the firm values inventory using direct costing or throughput accounting. We haven't talked about that part of Chapter 8 yet, but that's not correct. These costs are divided up between the firm's value streams and are reported as an allocated overhead cost of these value streams. No. No allocation of overhead costs because we're using actual costs entirely. And these non-value stream costs do not move over to the left on the screen there into the value streams at all. They stay in their little columns. So that's incorrect as well. So this has to be the right answer right here. All right, there aren't a ton of these, but I felt like the only way I felt like it was an important learning objective to become familiar with value stream income statements, or plain language income statements, as they're sometimes called, because you might encounter some lean accounting practices in your time with a client or with a supply chain partner or with a company you're working for yourself. And so the only way I could think of that really worked to test you on these instead of making you build a value stream income statement, which I have done it at one semester, just didn't work well for the time to learning ratio that it had, was to have these conceptual questions. So I have a few of these in here, and that's how you tackle those. You take those, basically you take these three characteristics and test your knowledge against that. All right, so let's talk about backflush costing. And yes, the word flush is in there, and yes, lots of potty jokes can go in there, and I might make a few occasionally as tastefully as I can. But the basic idea is, how can we simplify the accounting process as much as possible? Specifically, I'll just rewrite this, but we're going to keep this same idea up here. So the traditional way is to have three income accounts: raw materials or direct materials, work in process, finished goods, and cost of goods sold. And as we incur costs, we're debiting, and as things are completed, we're moving over, and as things are sold, we're moving over. These are all, that's the typical flow of costs as we incur them: product costs and manufacturing costs. Now, and that's useful for a few reasons. We get to track the costs, and we get to know where they are in the process. If we're taking a lean approach, we're likely trying to decrease inventory as much as possible, at least approach in some meaningful degree a just-in-time model. Even if we're not truly just-in-time, we're going to be more just-in-time than we were before, because one of the key costs that are an X6 or an X7, which are only driving the cost function and not driving revenue, are inventory costs. You hold a bunch of extra inventory, you have the risk of theft, you have the cost of the warehousing and employees to man the warehouse, you have the cost of obsolescence, because Chewbacca masks are only in season for a while and then they go away. And remember that? Remember Chewbacca masks? Big run on them. They couldn't get them in stores after that one video. And then nobody buys them now. So anyway, you have the risk of obsolescence as well. So you're going to be decreasing the value in your inventory counts anyway. A big piece of the reason why you would even be tracing the costs across here goes away. You just have smaller values in each of these accounts. You're less concerned about where the costs are along the path. And so what you do is you say, I'm not bothering with this. Instead of this flow right here, let's do it backwards. And as we incur costs, they get debited to cost of goods sold immediately. We pay a worker, a direct worker. He or she's working on the line. It's a debit to cost of goods sold. We buy some raw materials. It's a debit to cost of goods sold. We pay some factory overhead. It's a debit to cost of goods sold. And then at the end of the period, we say, oh, you know what? We had a couple units left over because we have very low inventory levels. A couple units left over here and here. So we will backflush a little bit of cost as appropriate to those areas. So that's the basic idea of backflush, is accumulation in cost of goods sold of all product costs, and then the backflushing of costs at the end of the period. So it goes hand in hand with a periodic system. Typically, it's almost always using, at least as it's taught anyway, a periodic system where you're not continuously keeping the balances, but at the end of the period, you're going to be doing the backflushing. Some of the questions in here hinge on you understanding the timing like that. So, for example, right here, this question right here, we can actually answer this question without any knowledge of what direct costing means or anything like that. So, at least I think we can. Well, we'll go with that. We'll try that anyway. So a firm uses backflush costing on a direct costing basis. And in this context, just know that means that all of these are product costs right now. It incurs the following costs this period. All right, so it has these three categories of product costs that it incurs. The firm's total units in process is 1897. Total units completed and in process is 1897. The firm has 45 units in process and 16 unsold units in finished goods. All right, so overall, we completed 1897. We have, at the end of the period, we count up, we say, oh, we still have 45 units in process and 16 units unsold in finished goods. So we're going to have to backflush an amount from our cost of goods sold to those areas. The firm has $577 of unused raw materials left over at the end of the period. Okay, so we also counted up, we have this amount here, so we need to backflush that amount to raw materials. And I'm kind of abbreviating, and I won't. There's one caveat I haven't explained about this yet, but it's irrelevant to this question. The key is, the question said, what is the balance of cost of goods sold account before the firm backflushes cost inventory accounts? So we don't yet need to know how to decide how much to backflush. We haven't backflushed yet. So if costs are accumulated in cost of goods sold and nothing else has happened, has cost of goods sold stay the same? Yeah. Nothing. There's no lean fairy that comes in at night and steals the cost out of cost of goods sold. Like that's not a thing. It's not the tooth fairy of lean accounting. If it's there, if we debit it there in the first place, it's still there. So at the end of the period, before we backflush any costs, it's really just the sum of this and this and this. That's the answer to that question. So some of the questions hinge on you knowing the timing of backflush, and it's really as simple as that. It starts here, or when we debit it to here, and we backflush it in the period to account for the fact that we still have some in finished goods and some in work in process and some in raw materials, some cost there. All right, so let me sum those, and we can answer that question. All right, I'll create a new sheet. It's going to be chapter 8. Which one? All right, yeah. Yes, some will. And then you need to know this step and then the next step of how to calculate the backflush entry. But some of them just depend on you knowing that, oh, hey, all costs are accumulated in cost of goods sold, and then these are all product costs, so that must be the answer. So this is the COGS before backflush question. And I'm just going to type in these and sum them, and that should be our answer. Yeah, we will. That's the next step. Yeah, exactly. Make sure I copied them over. All right, good. All right. So some of the questions rely on you knowing the handy illustration. Let's double check, see. All right. So some of the questions rely on you knowing the timing. This handy illustration shows that backflush is technically a question of where cost is accumulated, just to drill home the fact that it's a question of some of the questions rely on the fact that costs are all accumulated in cost of goods sold, and you backflush some to fill inventory accounts. The tricky part is that backflush does imply that you have a periodic recording interval. And these almost always go together, even though technically that's a separate question. They really do go together. And in every question in this test bank, assume it's on a periodic basis. All right, now calculating the backflush entry. Well, one more time, one more emphasis here. Upon purchase of goods sold, we debit costs of goods. Upon purchase of materials, I read two lines together. I don't know why. We debit cost of goods sold, 50,000. Credit accounts payable, 50,000. Upon using labor, debit cost of goods sold, 91,000. So we're debiting costs all over to cost of goods sold. Upon machine maintenance, debiting cost of goods sold. In a period, we're going to be debiting to inventory accounts, and I just generalize what this means, and crediting to cost of goods sold. So like I said in the textbook here, I was intentionally vague about the debited entry here in number 4, because we're going to go over that now. All right, so this is one of the things that happens. One of the things that happens is we actually are going to change the inventory accounts, because it doesn't make as much sense to do it this way. We're going to have two accounts that much more line up with the category of the cost, the type of the cost, than its state of completion. So just this is going to be similar to process costing. Again, they're observing, hey, direct materials and conversion costs sometimes move in different patterns. And so we're going to have RIP, that's R-I-P, like rest in peace, for direct materials, but that stands for raw and in process, R-I-P. And it's useful to remember that. It's really R and I-P, because there will be times where the question gives you a raw component, like that 577 in the last question, $577 of raw materials, and an in-process component. There are also 45 units in process, and we're going to have to figure out how much those cost for direct materials. And so it'll have a raw amount and an in-process amount. That's what RIP stands for. And then if we consider conversion costs to be a product cost, which is true this week and it's not true next week, spoiler alert. Direct costing, which is what we're covering, backflush using direct costing this week, says, yeah, there are conversion costs. Direct labor and overhead are considered product costs. We're going to use them, inventory them, and consider them conversion costs, create an inventory account for them. Next week, we talk about throughput accounting, where you go even further and say, the only truly variable cost, the only truly product cost is direct materials. So that's all we're going to record inventory at. So we don't have this account. But this week, we have direct labor and overhead. As we incur them, they go to, when we have in-process units, their direct labor and overhead costs go to the conversion cost account. That's what CC stands for, just like in Chapter 6. And then, we have typical finished goods and cost of goods sold. So we're going to have a debit when we backflush, for example, that debits RIP, debits conversion costs, and debits finished goods, and credits cost of goods sold, because it's moving out of here. So we're going to be, I drew the arrows from the wrong place. Credit here, 2 debits over here. Okay, let's talk about how to do this. How to do this is to think about it very, 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 very simply, and be very careful not to transfer over all the complications of process costing here. So for example, in this question right here, if it asked me after, I would say, here's the denominator, here's the numerator, now I have a per unit product cost. That's it. No total equivalent units in the denominator. No, do I include prior period costs or this period costs? Is FIFO or not in the numerator? Nope. We just have our total product costs, whatever is considered product costs. We're using direct costing, so all 3 of these are considered product costs. over this. And let's figure out what that is. So if it were a rich after question, sorry, I channeled Tevi there. If it were an after question, we have numerator, total product costs, and we have 1897 denominator, which is total units. So that's how it's going to be labeled in like every single question. The firm's total units. You just care about total units, which means that our cost per unit is $21.72 is what it would round to. We'll leave it unrounded because we're going to do some calculations. I got ahead of myself a little bit. What I'm going to do now is I'm going to actually split that out into the materials portion and the conversion cost portion, because I'm going to have to get different entries for the materials and conversion cost portion. So I'm going to create this is the DM cost per unit. Nope. Just copying things over. And then take the conversion costs, which are direct labor and overhead. Any overhead that is considered a product cost, which in direct costing includes the variable overhead. And create separate number right there. These two together, they sum to 2772. So right there. But I'm going to keep them separate for my calculations. Or now I've separated them out because that's going to be useful. So what do I call this? This is CC per unit. All right, and so now I need to figure out what the debit to RIP is. We also have 577 of raw materials. So there is a raw portion and an IP portion, in process portion. I'll put this an portion for raw and an IP for in process portion, because there's 577. We counted up and we said there's $577. This is the question right here, of unused raw materials. So we need to backflush that back out to the raw materials portion account, the RIP account. That part has to go back there, and then each of these 45 units in process costs us $8.67. So we need the IP portion. So we have 45 in process units. Just copying down things from the question so I can use them in cells. Unsold, which means finished goods. Okay, so we have our direct materials cost times the number of units in process. That gives us our in process portion. No minus. I want just to show an equal sign. So our debit to RIP is $967. There's a raw portion plus the in-process portion, which was calculated by saying we have 45 in-process units times this rate we figured out up here. And this is our RIP debit. We have a debit to conversion costs, and there's only an in-process portion for that. just multiplying those two. We have a debit to finished goods. We're backflushing to finished goods now. And they don't have a, we're going to leave it here. It's not, doesn't fall into this table here. Finished goods have all of their costs. It includes the direct materials and the direct labor and the variable overhead. So I'm going to use this total cost right here per unit times these 16 unsold units in finished goods right here. And so that's going to be our debit to finished goods, which means that we must be crediting cost of goods sold to balance that out. So our cost of goods sold account before backflush was this. We backflushed out 2267.668. So that's our balance after backflush. Okay. Yep. Right here? Yeah, I took the number of units unsold and multiplied it by the overall rate. And you don't have to calculate this over, you could just sum these two. So we could multiply it by this plus this. We get the same thing. This right here? Or here? Yeah, it took units in process times the CC per unit. Did you see it long enough? Did you want? Yeah. You got it? Okay. So the bottom line is you like the before questions. Right? I like the before questions too. I like that. I'm like, I can logic this one. Yes, let's do that. Yeah, okay. I copied it over from the question. It's just right there. I'll have to give that to you if there is a raw portion. I just have to tell you. Oh, wait. Oh, I just didn't know where else to put it. I should have a different column for complete portion. So it's not, it's not the raw portion for finished goods. It's just the only thing for finished goods. Yeah. Different. Yep. It just has to balance. Yeah. Yeah. Yes. So this is our before balance of cost of goods sold minus the credit here that we figured out. Okay, so I went through the whole process. If I were trying just to answer the after question, I could skip some steps. Because look what I've done. I've multiplied the DM rate times 45, and I've multiplied the conversion cost by 45. And then I multiplied them both by 16. So really what I've done is I've taken the cost per unit and multiplied it by these two right here. It'll be the same thing. So let's look at this. Let's look at it this way. The overall backflush debits are going to equal the raw materials plus this times the sum of this. And I get the same number there. So I'm going to be backflushing that amount back. If all I want to know is the cost of goods balance after, I don't need to know how much is going to finished goods cost, conversion costs and RIP. I just know that the total amount is going to be 2267.668, which means I'm going to have to credit that total amount to cost of goods sold. So the balance in cost of goods sold is going to be the 52,000 way up there, which is off the screen, minus that 2267.668. That shortcut requires us to understand what's going on, which I think given a week of focus on this quiz is like laser focused on these questions here. I think there's enough. I think there's a good amount of material to time on this week. So I think we'll be pretty comfortable with it at the end. So I could simply say this amount minus this amount, and I get the same thing right here. Just get total backflush debits, because I know I'm going to have to debit that 577 for raw materials. I know that I'm going to have to debit a full unit's worth of in-process units, even if they're being split up between RIP and cost of goods sold. Overall, I'm debiting a full unit's worth for those 45 units, and each unit costs me $27.71. I don't care about equivalent units. There's nothing. No, don't go there. That's not here. Chapter 8 is a equivalent unit free zone. And I know that I've got 16 unsold units. They're going to get a full charge as well, $27.72. And so I can just multiply out to figure out what the total debits are and say, oh, well, I'm also going to have to credit that from COGS. That's what that means. I'm backflushing it from COGS and distributing it out to the different inventory accounts. So you don't have to do all of this if it doesn't ask you for the journal entry. And there are questions that ask about the journal entry, but think about the type of questions that are asked on here. Multiple choice or open answer. Neither one is amenable to making you calculate every line of the journal entry. The multiple choice ones, remember our 7-1 quiz, some of the journal entry pieces made those questions easier, because you could say, oh, well, I know, for example, back in 7-1, we were doing like direct materials, quantity variance, for example. I know the amount we bought. I know the amount we used. I know the amount that is standard. I can then figure out the plug based on the journal entry. Or similarly, I know that this journal entry is set up wrong here. That can't be the right answer. I've increased my odds. I know this journal entry here is set up wrong. I've increased my odds. Now it's just 50-50 if it's a multiple choice question. So we have a number of questions that are like that. Let's look up. I think we have one right here. All right, look at this one. All right, so here's a question. A firm uses backflush costing and values inventory using direct costing, which is all we're doing this period, this week. And I want to address this right after this question. What is this direct costing thing? And like all actual amounts are equal to budgeted amounts. That's the assumption that we're going to use entirely, because I want to make this simple. Note that some of the amounts below are on a per unit basis. So I don't give you the total DM cost. I tell you DM per unit. So I already calculated that for you. I am nice sometimes. See? DM per unit, DL per unit, variable overhead per unit. We have I gave you fixed overhead per unit as a red herring. Total completed and in-process units. And how many units are in finished goods, and how many units are in process. And then down here, we counted up raw materials. We have $50 in the warehouse. So which journal entry appropriately backflushes cost to inventory accounts? Let's just look at these to start. Two of these cannot happen. They are not a backflush. Two of them are debiting cost of goods sold, increasing cost of goods sold. Okay, if you flush the toilet and the level rises, that's bad. Right? Okay, we know our toilet science. Good. Don't increase cost of goods sold when you're backflushing out of cost of goods sold. You're trying to flush those costs out back to the I said it would be tasteful. I'm sorry, it wasn't very tasteful, the joke. Fine. It's the best I could do on such short notice here. So B and D or 2 and 4, whatever it is, those are not in the pattern of a backflush entry. So we can rule those out immediately. And guess what? We also know, at least you will, that missing the raw portion is a perennial testable item here. And that is the difference between A and C. $50 in RIP, which happens to be the raw portion here. So without doing any calculations, I am 99% sure that is the answer, because I ruled out 2 that don't follow the pattern. And I got inside the professor's head and said, oh, well, he's likely to test me whether I remember raw materials. And I bet that $50 difference is due to one of those entries forgets raw materials in the RIP. It forgets the in RIP. But we can do it real quick. 225 with just the RIP portion. 225 times 100 gives me $225. So that's this right here. It omits the portion right there. So 225 times 100 gives me the IP portion, plus the 50 gives me 275. So that's the right answer. And conversion costs are the same. Finished goods are the same. Cost of goods sold has to be the same, has to be different, because it has to balance. But it's different because RIP is different between these two. So that's the right answer right there. All right, so if you know the logic, that's a portion, 10, 20% of the questions, because that's before the entry cost of goods sold questions, for example, you know the timing and logic of backflush. If you know what the journal entries look like, that at least increases your odds considerably for another 25% of the questions. And then when the rest of them where you do have to battle it out and do some calculations. It's never asking you for a million calculators. Usually not asking you for a million calculations, I should say it that way. All right, direct costing. Let's talk about that. So that's important here. This week is all about direct or variable costing. It's either called direct costing or variable costing. And I think in every question I use direct costing. I call it that. I know in practice it's also sometimes called variable costing. They mean the same thing. At least every single time I've seen it definitively defined, not just some internet site, but definitively defined, they are defined the same way. I showed this the other day. Before we took a break and forgot everything last week. I showed this before the break. The idea that there is an incentive to overproduce when you're using absorption costing. Why? Because you're absorbing some fixed overhead costs through the magic of overhead allocation. And so if you overproduce, which means you'll have a backlog of units, you'll increase your finished goods units or your in-process units, increase the number that are in the backlog there, then a higher proportion of those fixed costs, in this case, the higher proportion of this 20,000, are going to be pushed onto those units and stuck on the balance sheet and not hitting the income statement. Variable cost gets rid of that by just creating a nice HOV lane for the fixed overhead. It's always going to be charged this period because it's fixed. It's not. There's no reason to do it this way. To include the fixed overhead in your overhead allocation, this PDOH rate. And so instead, we are taking sales minus variable cost of goods sold, which is direct materials, direct labor, and variable overhead. And we get a contribution margin instead of gross profit, and the fixed overhead, subtract that away, and operating income. So we're much more, this is in line, largely at least, if not entirely, with Chapter 3, the idea of a contribution margin income statement. And this operating income will stay the same no matter whether we produce at demand, we overproduce a little bit, look, it stayed 22,000, or overproduce a ton, it stayed 22,000. That's the reason why lean practitioners love this idea. They're like, we really don't want to incentivize the managers to overproduce because overproduction leads to inventory backlogs, and inventory backlogs are expensive. It's a wasteful cost. Let's cut that waste. Let's not give people the incentive to overproduce. Okay. And so as a result, if you're looking at the questions, what that means is, here is the traditional absorption costing method. We consider direct materials, direct labor, variable overhead, and fixed overhead to be product costs. Under direct or variable, we only consider direct materials, direct labor, and variable overhead. Really, all it means is that we are omitting fixed overhead. So sometimes there will be a red herring in there that, look at this fixed overhead rate. Don't you want to use it? Don't give in. You won't use it here. And then, again, spoiler alert, next week, when we get to throughput accounting, it's just direct materials. We've cut out direct labor and variable overhead. That's the only cost we consider a product cost in that context. So not only does that get rid of the I won't go through all the logic of it, but the idea is not only does that make it so that there's not an incentive to overproduce, there's actually a strong, there's a force in the opposite direction. You have an incentive to cut as close to just in time as possible by cutting out direct labor and variable overhead from inventory costs. If you want to see that logic, because I know you're all curious about that. Let's go back to, no. I won't get to it right now. The maaw.info site that the USF professor put together, that was kind of the inspiration for my own textbook. His chapter on it goes through the logic of exactly how the numbers work out to, if you use throughput accounting, it punishes you for any inventory you produce. It adds an extra cost to your income statement as a result of that, effectively anyway. All right, well, that's it. Let's stop there. Again, we'll go over some more of the chapter 7 stuff that's due this week because it's extension, started Thursday. And email me or ask for specific questions then, and we'll keep going on chapter 8 then too.